Hey Gurus, it's me again. Welcome back to the third part of C# for Pentesters. Today we'll be exploring a bit more about DLL injection, how a classic DLL injection works, how malware tries to. Actually, it's an old technique, so we can explore through the coding, so we will get more clarity on how the malwares were injecting, or currently some malwares are injecting the DLL into uh, the remote victim process. As I said, it's a pretty old technique, so almost all the AVs will detect. And if your AV is not able to detect this one, you have to change your AV. That's all. Yeah, let me explain the process first. Let me take you through the APIs involved in this one. These are the APIs involved in this one. If you had a look into my previous session, especially the second part, process injection, you would have come across the open process, virtual X, write process memory, and create remote thread. These were the APIs that we were using to inject our shellcode into a target process or victim process. Today, there will be two more APIs that will help us to load the DLL and inject that code in the DLL into the remote process. A bit difference from the main difference compared to the previous technique is here to we are going to take the shellcode from the DLL and inject into the victim process. But here is we are not going to do it directly. We have to do some tricks to load the actual DLL content to the victim process. So I will explain first how it works. Then we will go through the code and use more clarity how it works. So here the process. First, we there are two ways to deploy it. Like either you can download the DLL, either malware can download the DLL from your server at the time of malware running. Then the malware has to save it somewhere on the disk. Then from there it can inject into the remote process. On this demo, I will show you how to create the DLL and deploy both on the victim machine. The main problem with this one is we are creating an artifact. We are touching the hard disk, so it is easy to trace back all the stuffs happening on the hard disk. So this is the process. The malware opens the remote victim process using the open process, and then it allocates the virtual x. Using the virtual x, it creates a base address, virtual space base region for our shellcode. But this time, compared to the previous one, here we are writing the DLL path on this virtual alloc API instead of the DLL. Compared to the previous one, we were trying to create a page read execute memory with memory reserve and commit mode. But here we are supplying the path of the DLL on the virtual logX. Then the actual DLL content will be writing into the victim process using the write process memory. And finally, we load the DLL path. The DLL we have to call the DLL using the load library A. Load library A is a tricky function actually. We can't directly use it to get a handle. So even the description from Microsoft, it says it loads a DLL, but here it says you need to call this getproc address if you want to get a handle to the process. So that's what we are doing. We will be calling this load library A with the getproc address, so we will get actual handle to the DLL to call the DLL function. So whenever we call this load library A, that function will call the actual DLL that's loaded into the process using the write process memory. Then we create a remote thread using the proc handle to load library A. The final step actually it creates an executable thread. So whatever content that we have given, the actual shell code inside the DLL will execute it, when we call the create remote thread. Don't get confused on this one. I can take you to the code and we'll explore a bit more. Before going to the actual process of this one, first I will show you how to create a DLL, then how to export a function and test our DLL just to ensure that it's working fine. So let me take you to the process, actual process of the most interesting part, coding. Here I'm using a classic DLL project. So it's very easy to create it if you have Visual Studio Code. Either you can use it Visual Studio Code if you have code blocks. This is another easy way to create it. I'm just showing both will work fine. The only thing is if you are using this one, just ensure that if you're targeting a 64-bit machine, then you have to change your compiler settings and ensure that you have tick this box hyphen M64. This will ensure that you are targeting a 64-bit uh, victim machine. So I'm going to explain this code in Visual Studio. The same can be done using Visual Studio. It's easy. If you are familiar with this one, Visual Studio environment, just when you're creating a new project, try to create a new project with DLL dynamic library with exports. That will help you to create this template. You don't need to create this template. This will automatically come here when you are trying to create a new project in CPP. So I'm not going to take you through the entire code line by line because it's if you are interested in programming, definitely you can understand this one. It's CPP and this is one of my favorite languages other than Go and C#. The only thing is you need to do everything manually and you have to dig deeper into every time. But the Windows API call is everywhere. It's same. The process of calling the APIs and supplying the parameters, almost everything is same. In fact, it's more direct from when you're doing it from C++. So I can tell you what exactly this one is or is here, happening here. This is the main entry point of this DLL function. So whenever you're going to load this DLL using the load library, that's the load library function will cause this DLL to reach here on the DLL main, and whenever it sees the reason for the call, there's a switch case here. It's just like an if condition. If the reason is DLL process as attached. I'll show you what exactly Microsoft says about this one. So see, this is the process attached. Normally, this is useful for initializing your global functions or global variables whenever you're calling a DLL on a normal functional way. So what happens when you're using actually this is starting up. Whenever the DLL is going to load into memory, whatever you are given inside that DLL process attached switch case or if condition that will get executed as an initial setup. So or whenever you're calling the load library, uh, this whatever you have given in this switch case is going to get executed. So what we have done here is as per the documentation. So whenever the load library a function is going to get called, we call a function is a user defined function. Uh, it's pretty similar. The signature is pretty similar if you are compared to C#. It will be easy for you to understand. It returns an integer value and it's a normal function, no parameters. So it just does the same thing of a classic P injection. What it's going to do is, of course, we have to fill our shellcode here. So it takes a shellcode and create a virtual memory region, and it writes a shellcode there. and it moves the shellcode to the memory region we have created, and we it just create a thread, and that will help us to execute that shellcode into the region. So suppose if this DLL is going to get called by the victim process. So the call comes here on the main function, and the reason is the process attached. So the process attached means it executes this function directly. So this is a dangerous part. Like instead of normally this DLLs, when we develop the DLLs, we use this call DLL process attach uh, condition for initializing the global part of the DLL functions, or setting up our initial uh, variables or some other stuffs that will help for the DLL to call other functions properly. But instead of that, here we are going to call our malicious function that has a shell code that will create a virtual memory region, and it will get executed on that same process. That's what here is going to happen. So the first thing we need is the shell code. So one more thing, we can do the same stuff using MS Venom. We can directly create a DLL. That DLL is doing the same thing that we are going to do here. I'm doing it manual way just to give you more clarity on what happens when we're creating a DLL using MS Venom. I will show you both. First, let me create the shell code. So here we are going to create the shell code. Uh, Let me check the IP. It's not changed. So yeah, we are going to create the same shell code. Before creating the shell code, we can say, I think DLL, what is that? Hyphen type DLL hyphen O test dot DLL. I think this will create a DLL for you. LS. Yeah, either you can make use of this DLL, or you can create your own using the CPP. I prefer this second method that I explained. We already have a CPP template. The only thing is you have to just you have to inject your shellcode there. So I'm going to do the C# one. I need the shellcode after removing all the bad characters. If you want to know what exactly the shellcode is doing, please do visit the previous videos. There we explain a lot about this one. So I'm copying this one. Oops. Let's click on here. Copy this. Do yep this file. I'm replacing this with a new shellcode. This is nothing but I have to take this shellcode there in my coding machine. So I'm going to start my Apache. So this will be available now on my coding machine, so I can download there. Where is my browser? Yep, here. Let me. Yeah, it works fine. Shell, I think. Yep. Yeah. Let me take this shell code, and yeah, this is the same template. You can do this here, but I will show you exactly on Visual Studio how to do this. Paste your shell code here. So remaining everything is same. One more thing I forgot to explain here is we are exporting this function. This directive tells the compiler that we are exporting this function, so you can call this function uh, after importing this DLL to somewhere. We can call this function. This is an exported function. Just like I can say the example that we are going to explore now on the next program. As I said, the LOL library A. Actually, the LOL library A is an exported function from the kernel 32.dll. That's why we were able to use that function. So just like that, we are exporting this function just to use that function somewhere else. As an example, I can show you, we are going to test this DLL before we are supplying with the actual exe. There we can call this function using the run DLL32. So we can just test and confirm it the DLL is working fine. So here we have pasted the shell code. If everything is working fine, I'm going to what's the function? What's the name of this one? Process inject. Yeah, it's an inject. Inject is the project name. If where is that? Okay, I can take directly from here just to ensure that it is listed here and is going to build on 64-bit on release mode. Yep. Right click and rebuild. Yeah, it did build this one and it's available on this path. I have already opened the path. This is the DLL path. Yeah, inject.dll is here. So I'm just copying this one to inject.dll to my shared drive to make it accessible. Yeah, it's the previous one there. Now it is available on my VMware victim machine. So I can I'm copying it here. So I have this inject.dll here. So we are going to test this whether it is going to work or not. Before that, we have to start our Metasploit server because we have used the HTTP meter reverse HTTP. So we have to start our console to ensure that the server is up and running here. Yeah, now it started. So what we have to do to test this DLL is run DLL32.exe, then the name of the DLL, then what was the function name? This is a function name that we exported. So this should be available on that machine, not on the machine, on the DLL that we exported. So let me come here. Get my shell. So if this DLL is working fine, we will get um, the victim on this machine. A session will get opened. So yep, it says missing entry. Let us go back. But see here you got a session. Even though it just generated an error, you just go to the session here. So if you say -i1, current session, I mean, just check the sessions. You have one active session and just interact with that. Go back to the shell. Yeah, actually we just uh, got the complete shell from the victim. So that means our DLL is working fine. We have exported one function, even that function is working fine. So the next step is we have to manually uh, inject inject the DLL using our uh, process, the process that we are going to create. Then we will be supplying the same DLL and exe to the victim. So let us just have it running here, the process. Next is our actual process, the C# code. Till now we did develop our DLL. So the next thing we have to do is uh, till now we did develop all the DLL setups, like we exported one function and tested it. You don't need to do this if you don't want to do using DLL 32 or something like that. So just we have confirmed this one now after exporting that function. Now the actual process comes here. The code that I explained you a bit earlier in the beginning, the process of this process is going to happen here now. I will go through the code and do explain once again. This is a DLL name. Actually, this name should be matching with the DLL that you are going to deploy. It's DLING or whatever name you can give. Just you should match with the DLL that you are going to build. So what happens here is we are just taking the full path of the DLL and don't need to do this on real time. Just confirming it's returning correctly. I'm going to fetch explorer.exe just like we did last time, because that's the most safest process, one of the safest processes. In fact, in Windows we can safely inject into. So after uh, taking that explorer.exe, we are taking the process ID. Then we need to have a handle to that process, explorer.exe. So we are getting that process handle using the open process. We are doing with all access right. And again, I hope you remember this will work only if you have proper access rights on that environment where this exe is going to run. So after getting that process handle, we create a memory region on the process uh, just for our DLL. Here, the main difference compared to the last one is we just check the third parameter. We are writing the DLL path to this virtual alloc X. So this will create a virtual memory region for our DLL to get executed with the DLL path in that mentioned in that. So what happens after that? We write into the explorer.exe process using the same target process handle we had after we got that from using target open process. Then the base address. Base address is the region that we recently opened using the virtual alloc X. Here this actual process happens. We are taking the entire DLL and taking the bytes, converting that into the bytes. Whatever we have, the shell code, everything will be returned into the process memory that we already created using virtual alloc X. And we are writing uh, with the DLL full path length. We are specifying the length of the this is a length of the memory that we need to write and how many number of bytes are returned to the target process. So we already did that here. So the next thing we have to do is we have to call this DLL, or we have to uh, get the DLL content to get executed. So that we are doing that is using the load library A function, but actually we need a process handle for that. So we can't directly uh, get into the process handle of that DLL path. So what we do is we call the load library A. As I said, load library A is just like the function that we create on the DLL, is an exported function from the kernel 32.dll. So we call that using the get module handle. So we get the handle of the load library A, and we are getting the process address uh, of that load library. So we are using this process uh, load library process handle and supplying to the create remote thread. So now the create remote thread is going to write into our target process, the explorer.exe, with this load library A function, and we are loading the actual virtual from the region virtual X that we already created. So what happens here is now the virtual base address is has a DLL path, and we already have uh, we have returned the entire content of the DLL into the process using the right process memory, and we got the load library function that will help us to call the load the library actual DLL into the process. So what happens when the load library function calls, when it's going to execute, or like when the this application calls the load library function, the call comes here to the main function. And just because we have specified the DLL process attached, this specifies what should happen when the load library function will get called. So here we are saying it has to call our shellcode injection function. So as usual, if everything goes well, this will load that shellcode into the target process memory, and it will get executed, and we will get a reversal after injecting the entire DLL content and shellcode into the explorer.exe process of the victim machine. So this is the theory behind this one. So now I'm going to build it. So you have to be careful about the name of this one. Here again, another thing. Either you can do it like this. The Now I'm going to show you this way. There's another way. You can remotely do this. Like there's a class called web client in C#. You can use that to download it remotely from your server, and you have to save it. Again, you have to save it on the disk. That's a must thing for normal classic injection. You have to save it on the disk. Then you have to do the same thing. Either ways, for an exercise part, you can try that. Download it from the remote server that you set and save it to the victim machine and do that from there instead of supplying both and giving to the victim. So here I'm just is I use DLL dot DLL. So either you can change the DLL name here with the actual DLL name they already built using the CPP method. I mean from the CPP function, or you can change the target DLL you already created, rename the DLL that you created. Whatever it is, it should match. Whatever you're saying here should be there on the disk location. Here I'm not specifying any path. That means this DLL should be there on the same path where the exe is going to run. So this is a DLL inject project, and I'm ensuring that we are going to make it on 64-bit. DLL inject on 64-bit. I'm just making it So this is inject. I already had this one. Yeah, what's the time? Yeah, it's 1:34 for me. Inject. Yeah, actually I did copy this for the previous. Before doing this demo, I just tested this one, so I copied the previous DLL here. So we just need only this one, DLL inject.exe. So we are going to copy this one to so no, no, what I did. Oh my god, the command was wrong. Oops. I had to copy DLL inject.exe to VM share. So oh, it's already there. Replace that. I just did it. Now we have to copy uh, the we have to copy what was it? DLL inject. Yep. Copy the zip drive. Copying here. So one more thing. Just because I didn't change inside the code, I'm renaming it here. DLLinj. DLLinj. I think this was the name I used inside my app. DLLinj. Yep. So now everything is set up. Now we have the victim machine has the DLL actual malware that is going to load this DLL and going to inject into the explorer.exe. So if everything is working fine, we will get back our shell, just like when we tested the DLL. Let me go back to our server. Yes, our handler is running here. So now it's, yeah. So suppose imagine the victim is going to run this one. Is everything is, I expect everything happen as we expected. So go back to our, yeah, we got the shell just like the previous one because we already ensured that the DLL was working fine. So if there was any other error, that should have been on the second exe that we created. So now what happened was uh, the exe that we deployed did load the DLL and execute load the DLL and injected the DLL shellcode into the explorer.exe of the victim machine. Just confirm that we have an active good session. We have only one session. Yeah, is loaded as we explained last time. I expect this even if you close this function. I mean this exe is closed, and this will even after this one you will have this session. Where is that? Just because we have see this is working fine, and I'm just exiting it. So this is working just because we injected our DLL shell, I mean DLL that contains our shell code into the explorer.exe of the victim machine. So that's all for this demo. Hope you enjoyed this one. I do enjoy things where I'm doing programming more. Um, so if you, I don't know how many of you do enjoy programming and learning stuff. I'm just doing it for those who enjoy the core stuff, like who likes to know what happens whenever you're doing something using Metasploit or something. At least the basics. You can do the same stuff as I shown. You can create a DLL directly from the Metasploit and you can repeat the same steps. But this will be give you, especially when you're creating a DLL yourself and play with your stuffs. It will give you more insight on what you are doing exactly. So if you like it, please do subscribe and share it because I just want to continue this one. If I don't get more subscriptions, even I will get demotivated. But I'm planning more tutorials. I have more ideas on what to do on next steps. So I'll continue this C# for testers till some point where I can feel that at least who's going to visit my channel will get the basic idea of at least how a malware works, the basic stuff, basic techniques of malware, um, how a malware running on the victim machines, what are the techniques it uses to inject itself into the victim machine and get a shell back. So yeah, as I said, if you subscribe and share it with your friends who has the same interests, and if you like programming and if you like security, please be a regular visitor here. I can share more stuff with you. Yeah, till then, till the next tutorial I'm going to make. It's a bye from Alphas. See you then. Bye bye.